Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0235, indicates that the turbocharger boost sensor is out of range. This sensor plays a crucial role in monitoring the pressure produced by the turbocharger, which is essential for optimizing engine performance and efficiency. In the Honda Accord models from 2017 to 2023, the turbocharger boost sensor is typically located near the turbocharger itself, connected by a wiring harness to the powertrain control module, PCM. When the sensor detects values that fall outside the normal operating range, it sets off this fault code. Diagnosing this issue effectively involves checking both the sensor and its connections, ensuring system integrity, and verifying that the PCM receives accurate readings. Consequently, the troubleshooting process outlined here will help identify whether the fault lies with the sensor itself, the wiring, or the PCM, leading to an appropriate resolution. The turbocharger boost sensor is integral to the vehicle's performance management system. It monitors the boost pressure provided by the turbocharger, relaying this information to the powertrain control module, PCM. If there's an inconsistency in the readings, the PCM cannot optimize the engine's air-to-fuel ratio properly, leading to suboptimal engine performance. The sensor is specifically located near the turbocharger, connected via a 3-pin harness, which facilitates data transmission. When the DTC P0235 is triggered, it indicates that the sensor readings are not within the expected threshold, leading to suspicions about either the sensor itself or the wiring connecting it to the PCM. This error must be addressed promptly to prevent potential engine damage and impaired performance. Several factors can lead to the DTC P0235 being set. One common culprit is a faulty turbocharger boost sensor itself, which may fail to produce accurate readings. Additionally, poor electrical connections at the sensor or loose terminals may lead to intermittent signals being sent to the PCM, affecting the vehicle's performance under various conditions. Another reason for the DTC could be damaged or frayed wiring within the harness connecting the sensor to the PCM, which can introduce resistance or open circuits. All these factors must be assessed thoroughly to determine the root cause of the issue. Understanding these potential causes not only facilitates effective troubleshooting, but also highlights the importance of regular checks on sensor connections and wiring integrity. When DTC P0235 is present, various symptoms may manifest that can affect engine performance. One key symptom is reduced engine performance, as the turbocharger does not operate optimally without accurate feedback from the boost sensor. This leads to poor acceleration and overall responsiveness of the vehicle. Additionally, the check engine light will illuminate on the dashboard, signaling the driver that there is an issue that needs to be addressed. Another symptom could be inconsistent boost pressure readings, leading to either excessive or insufficient power production. If left untreated, these symptoms can cause further complications in the engine's performance, making it crucial for owners to address these warning signs promptly. The first troubleshooting step involves verifying that the vehicle is in the on mode. This is crucial because it activates the vehicle's electrical systems, allowing for accurate diagnostic checks. Next, the Honda Diagnostic System, HDS, should be used to check the parameters related to the turbocharger boost sensor. Specifically, the TC turbocharger boost pressure sensor value must be below or equal to 0.75 volts. If the current reading matches the expected conditions, proceed to the next step. If it does not match, this may indicate an intermittent failure. The system may be functioning correctly at that moment, prompting a check for any poor connections or loose terminals at both the turbocharger boost sensor and the PCM. This step is vital to identify if there is a transient issue that requires a thorough examination under the same conditions recorded during the DTC snapshot. In the second step, turn the vehicle to the off or lock mode before proceeding with disconnection. This ensures safety by preventing any unintentional electrical contacts. After the vehicle is off, disconnect the turbocharger boost sensor 3P connector. Now switch the vehicle back to the on mode and again utilize the HDS to check the TC boost pressure sensor readings. The critical step here is to verify whether the current readings align with the threshold of 0.75 volts or less. If the reading is as expected, move on to the next troubleshooting step. If not, further investigation is required to identify potential issues beyond the boost sensor itself, which could include the system connections and wiring integrity. Step 3 involves measuring the voltage between designated test points within the turbocharger boost sensor 3P connector. For this test, ensure the vehicle remains in the on mode with the turbocharger boost sensor connector disconnected. The measurements should be taken at two specific test points, terminal number 1 and terminal number 3 on the sensor's female terminals. The ideal reading you're looking for here is approximately 5.0 volts. If this value is reached, it indicates that the sensor is indeed faulty and requires replacement. If not, further evaluation of the wiring and connections is necessary to pinpoint the failure's exact location. This step is crucial in determining whether it's the sensor itself that needs replacing or whether further issues exist in the circuit. In the fourth troubleshooting step, begin by switching the vehicle to the off or lock mode to ensure safety as you measure wiring continuity. Jump the SCS service check signal line using the HDS and let it sit for over 1 minute, creating a stable condition for testing. Next, disconnect the PCM connector E, 80P, as further testing requires removing this connection. Check for continuity between the turbocharger boost sensors connector and the PCM connector at the specific test points underneath. The purpose of this step is to determine whether there's continuity in the VCC2 wire, which carries voltage to the sensor. If continuity is confirmed, the wire is functioning properly. If not, it indicates an issue within the wiring that needs immediate repair to restore correct operation. The final troubleshooting step aims to identify whether there is a short circuit in the P3 wire associated with the turbocharger's boost sensor. Again, ensure the vehicle is in the off or lock position and jump the SCS line with the HDS for more than 1 minute. After creating a stable test environment, disconnect the PCM connector E, 80P, as this will help isolate the circuit. Check for continuity between test point 2 on the turbocharger boost sensors connector and body ground, which can reveal if the wire is shorted. If continuity exists, it suggests that there is a short between the P3 line and ground that must be repaired. If the P3 wire is intact, it indicates that further investigations into the PCM or related systems may be necessary. After completing the troubleshooting steps, it is essential to perform a final repair verification. This process ensures that everything is functioning correctly before concluding the diagnosis. First, verify that the turbocharger boost sensor has been installed correctly and is fully operational. Next, double-check all wiring and connections to ensure that there are no loose ends or defects that could cause further issues in the future. After confirming all components are connected and functioning, test the vehicle performance under conditions similar to those that triggered the DTC initially. This final testing will confirm that the issue has been resolved. It is critical to ensure that the vehicle's performance metrics meet expected standards. To prevent future occurrences of DTC P0235, regular preventive maintenance is key. First, Incorporate routine inspections of all wiring associated with the turbocharger boost sensor. Look for signs of wear, fraying, or damage that could compromise functionality. Secondly, periodic checks of the sensor and connectors should be part of any vehicle maintenance protocol. Keeping these components clean and tightly connected can prevent electrical faults. Finally, replacing any components that show signs of deterioration before they become problematic ensures that the system remains operational and efficient. These proactive measures will significantly reduce the risk of encountering the same issue again, helping to maintain vehicle performance. In summary, effectively diagnosing and resolving DTC P0235 involves understanding the role of the turbocharger boost sensor and the wiring associated with it. Throughout the troubleshooting process, one must systematically verify the integrity of each component and connection, ensuring accurate readings are sent to the PCM. Following the outlined steps will help isolate any faults and lead to a resolution, either through sensor replacement, wiring repair, or PCM checks. Finally, implementing preventive maintenance measures greatly reduces the likelihood of similar issues arising in the future. By understanding and applying this information, owners will enhance the longevity and performance of their Honda Accord from 2017 to 2023. Please like and subscribe to the channel. See you next time.